find the integral of secant of x tangent of x all over the square root of secant of x dx. All right, so yeah, we got a lot of things going on here, right? But the first thing we realize is, right, well, wait a minute. I know that the derivative of secant of x is secant of x tangent of x, right? So let's take a look, right? And we also see a composite function, right? We say the square root with something inside. So, your first thought should always be, okay, I want u to equal what that inner function is, right? Which in this case is secant of x. But look at what happens here, right? The derivative, right? When we take the derivative of that, the derivative is secant of x tangent of x, which we actually see in the function, right? So that we can use the substitution to make this problem a little bit easier, right? Let's take a look. This is my u, right? That's my u right there. And what's my du? Well, actually, this is my du, right? It's secant of x tangent of x dx. So really, what does this problem become? It's the integral of 1 over radical u du. And this we can actually do, right? Let's think about that. This is actually what? U to the negative 1/2 du, which we can find using the power rule, right? So what happens in this case? We get u to the 1/2 all over 1/2 plus c. So of course that's just 2 u to the 1/2 plus c. And we'll just plug in that u back, right? So we get 2 times the square root of secant of x plus c. And this is the integral, which means what? If we take the derivative of this guy, right? If we take the derivative of this guy, we should get this right here. And we will, right? Because we'll bring out the 1/2, right? But then we'll have, by the chain rule, we need to take the derivative of secant of x, which is secant of x tangent of x, right? So that sort of helps us to know that, yeah, we got the right answer here.